1, chapter 11.1.1, section 11.1.1. I really like constructions. Anyway, hopefully you guys do too. I don't usually like doing them on computers, but it's way easier to make a video of that. I would definitely suggest you start by watching the introduction video so you know how to do a perpendicular bisector and an angle bisector, even though that's going to be kind of what we build up to. I like that introduction video because it explains why it works with the triangle congruence and the CP-CTC. Corresponding parts congruent, triangles are congruent. So just kind of running through this, the way this works is it has some instructions in the book, and then it asks you to do them in using a construction toolkit, which obviously you got one of these if you were in class. However, I'm going to use this website, mathspad.co.uk, and I'm sure there's a lot of these online. This is the one that I found, and it seems easy enough to use, so I've been using it. The thought would be I'm pretty much just going to focus on these toolkits and not so much on the lesson, although sometimes I will bounce back and forth to the lesson. The other thing is I'm going to read what it asked me to do, and then I'm going to go over to the construction toolkit and do it from there. So it says use your compass to construct two circles with different radii that have a center of point C. So no worries, I'm going to go over here. And the one thing I don't see is I don't see how to make just a point, which I think is interesting. So I'm just gonna, I guess, make, that didn't go well. I'm just gonna make a point. So it's not a very big point, but that is gonna be, I don't know, maybe if I hit it a couple times, it'll look a little bigger. So that's gonna be my point C, and I just need to make two circles. So pretty simply, I'm gonna drag this thing over, and I have one radius here, so I'll make a circle that goes around. And then I can either make this bigger or smaller. In this case, I guess let's just make it slightly bigger. And I'll do the same thing. So there you go. I have two circles using the same radius. Now it says in the space at right, use a compass and a straight edge to construct a line segment CD that is congruent to AB. Well, of course, I mean, this AB thing is sort of irrelevant. What matters is that I have a line segment. And what I'm going to do is I'm going to just try and make a line segment that's the same length. So in order to do that, and again, I hope you watch that intro video because it sort of explains why arcs actually have a lot to do with side lengths. So I'm just going to match this up, and now I know that on this arc, anywhere on this arc has the exact same distance, right? So I'll go here and I'll put another point. I will line this thing up, and I'll make my arc. And there we go. Now I know it doesn't matter where I connect this point over here. I know that all of these share in common that they're the same length, right? So there we go. I've matched that distance from here to here is the same as from here to here. If I go here, it says now in the space at right, construct a new line segment labeled EF that's twice as long. So that's fine. I'll go back over here. I don't know if I have an eraser. It doesn't look like I have an eraser. I just sort of have clear, and I don't really want to do that. So I know that this thing matches up already, right? We've already proven that this arc is the same. So what if I just go over here and I make one that goes all the way around? Now, if I make a line that goes through the middle, I know that this distance is the same as this. Well, so is this distance. So congratulations, that's now twice as long as this is. And I'll say I know a lot of this is easier for some of you guys to conceptualize than others. Some of you guys are going to think that construction is super easy, some of you not so much, and that's fine. I think the nice thing about having a video is you can rewatch it, and as always, reach out if you have questions. So in the space at right, construct a new angle that is congruent to this angle. So again, it doesn't really matter what the angle that I start with is. What matters is that when I make the angle over here, I copy it. So what I'm going to do, again, using congruent triangles, is I'm just going to make a length. I just need a straight line to start with. So I'm going to go over here, and I'm going to make an arc that is narrow enough that it hits both sides of this right here. Now, both of these sides. So when I go over here, I want to keep this thing locked. It's important that I keep this locked and that I have the same arc. I'm basically copying that length. right? I'm stealing that exact same length. So now what I know is that I have two parts of a congruent triangle, right? The distance from here to here and here to here are the same. So the distance from here to here is the same. And I know that the distance from here to anywhere here is the same as well. So I'm making like isosceles triangles. But what I want to do here is I want to copy this distance. So if I have this distance and I mark it up, wherever that point will be, it will all work out for me and I'll have congruent triangles. So what I'm going to do here is I'm going to measure this arc now. So it's really important I get the arc from this point to this point, and I'll mark this distance. So you can see what I have here is when I copy this arc, I now know that this distance from here to here, I'll put two arcs here, this distance from here to here is the same as this distance from here to here. And I know that because those angles have to be the same. Actually, I don't even know what I'm doing. I'm making the whole triangle. I don't even need to make the whole triangle, but I'm making congruent triangles, which I guess is good because now I know, because of CP/CTC, the corresponding parts of congruent triangles are congruent. So I know that this distance has to be the same as well. And there we go. These angles have to be the same because these triangles are congruent. And if the triangles are congruent, well, then I know that the parts are also congruent. So I have copied that angle. I guess real quickly, I just want to go back and show it more quickly without making the whole triangle, just so you can kind of see it. I guess, I don't know, maybe it helps to have the whole triangle, maybe it doesn't, but just if you want to do it quickly, you're just going to copy this arc. You're going to steal it over here. Then we're going to go over here and we're going to measure this arc. So I know that arc's the same. And I'll just go steal it over here and I'll connect it. And again, I have congruent triangles now. So when I go ahead and connect these points, I know that that arc will be the same. So I know that this arc is the same as this arc. Just without all the triangles. But again, if you did connect those triangles, you would have your congruent triangles, just to be clear. All right. Last one on this video. It says construct a circle centered on H. So we're going to start with a point that has a radius R below. Then use what you know about a regular hexagon to construct a regular hexagon. So this one's kind of interesting. So we're going to start with the point. Actually, I guess we'll just take this length of R. I'm sorry, we'll take this length and we'll call it, this length of R. And we're going to construct a circle with the length of R below. And I need to match this up. There we go. So I'll go over here and I'll steal this and I'll make a circle. Now, I don't know if you guys recall this, but essentially what happens is a hexagon, a regular hexagon has all the same lengths and the length is the same as the radius. And that's important because if I just start at a point and I make an arc, if I continue that arc along, all these lengths are going to be the exact same. And again, these lengths are all the same as the radius, which is important because I never moved this compass, right? I always left the same length there. So as I begin to move this thing along, I'm getting all these points. And that's important because the last point should match up with that first point. And you can see that it does. So there we go. Now what happens is if I connect all these points, I get the exact same length. And it's going to end up being a hexagon. I probably should have changed the color on that. I regret I should have done it in red or something. But you can, that, I don't know if is there an undo that I'm missing? I don't see an undo. But anyway, that one should have went there instead of there. And again, I know that all these lengths are the same. This length is the same as this length, is the same as this length, is the same as this length, same as this length, same as this length. But what's important about that is they were all also the same as this length, as that radius, which is why it never changed. So pretty easy to make a hexagon inside of a circle if you have a compass. You just start at a point and then keep that same arc going the whole way, and then you're done. So that is 1111. Again, reach out if you have any questions.